Hello all, in this video let's see why do we have dimples on a golf ball. So in order to understand this, let us first consider a case of ball without dimples. Let me consider a region around this ball where I am interested in studying the physics of the flow around this ball. So now let us consider the air is flowing from left to right. So as we can see, as we draw the lines of the flow of the fluid, in the case of the ball without dimples, the air flow would be looking like this. So let the flow velocity ahead of the ball be Vf and behind the ball be Vp. Similarly, the pressure ahead of the ball be Pf and pressure behind the ball be Pb. So the velocity in this case, the velocity behind the ball is greater than the velocity ahead of the ball. This can be understood from the relation of mass conservation, which says density times area times velocity is constant. So that is, velocity is inversely proportional to area. So as the area decreases, velocity increases. So in the region of the ball, like in the region where I have the ball, in this region the area is smaller than the region ahead of the ball. So as the area here is less, the velocity in this region Vb is greater than the velocity ahead of the ball. So Vb is greater than Vf. As we know, the relation between pressure and velocity is pressure is inversely proportional to velocity. So if pressure is high, velocity is low, and if velocity is high, pressure is low. So from this relation, we get that Pb, that is pressure behind the ball, is less than pressure in front of the ball. So as we all know that any object tries to move from high pressure region to a low pressure region, there will be a force that would be acting on this ball which is against the motion of the ball. This is the force acting on it. Now let's consider a case of ball with dimples. Similarly, I'll consider a region around this ball where I am interested in studying the physics. Right. Having seen to this, now I have dimples on this ball. Let us consider these to be dimples, though it may not seem like dimples. Let us consider this to be dimples. So as the air flows from the left, here we could see that the air would be much nearer to the surface of the ball as considered to the case of ball without dimples. This is because as we have dimples on the ball, this tries to create a local disturbance in the flow which tries to rotate, and we call this as turbulence. This turbulence brings the air far away from the surface towards the surface, and so the velocity near the wall of the ball decreases. So when we consider this to be Vf, the velocity ahead to be Vf and velocity behind to be Vb, here also we have the velocity Vb to be greater than Vf, but Vb here, like in the case with dimples, Vb of dimples is less than the velocity behind the ball without dimples. So now we have pressure behind the ball in dimples case is greater than the pressure behind the ball without dimples. So we also have a force that tries to slow down the ball here, but this force is smaller than the force that is generated when the ball doesn't have dimples. So force, let this be D, which means force in the dimples, and this be WD. So force with dimples is smaller than force without dimples. So as the retarding force is less in the case of ball with dimples, this ball moves more distance than without dimples.